Okay, so I'm gonna have to constantly admit people. I don't have enough people here. Let's see. What I would like for you guys to do at this point is just to have your homework out in front of you. And I just want to go over what to do, what to be expected in questions like these. If you struggled with it, if you couldn't do it, I completely understand. At least if you could do the last two problems for me, that's where I need you to be. The word problems that I gave you yesterday, they were nowhere near to the extent of how difficult these these three questions were. And it's really subjective, which means, there are multiple different ways to interpret one single word. And if you misinterpreted one thing, which you have perfectly logical, reasonable explanations to do so, you just get a whole different number and the whole different way of solving for these types of questions. So in any circumstances, when I go over these, if any question comes to mind and you say that I don't get this, you gotta let me know. Because I'm gonna do my best to address every single issue that you see with these word problems, and it's gonna get complicated for geometric series and things like that. And when I come up with these questions, because I'm the one who I like to create my own questions and things like that, if I'm using any of these resources for guidance or helpful tools, I want you guys to understand that, when similar things happens next time on an actual assessment, that you will be able to clearly see what I'm expecting you to be able to do. Okay, let's take a look at the very first problem. The 1560 members of the Great Pumpkin Society have a method of quickly notifying members. The president and the treasurer each contact 3 members round 1. Now let's put a pause button right there. I have had so many students come in and ask me, what is the first term in this sequence essentially? What is ace of 1? It seems like I start with the president and the treasurer, each contact 3 members. So in the beginning, I have 2 people, but each of those contact 3, which in total becomes 6. What did you, can you guys take a guess as to what, yeah, Emma? Oh, ace of 1, summation of 1, you think it's probably 8, right? But what's ace of 1, the first term? So I had some students who say 2, okay? What did you guys say? Did you say something on anything different? No? Did everyone say 2 for this one? You said 5? If you did 3, okay. So if you guys did 3 or 5, I think you were along the somewhere lines of making it, you gotta make it into a 6. One person contacting 3, well, the president contacting 3, treasurer contacting 3, that's a total of 6, by the way, okay? When I was solving this question, I made A1 to be 6. And here's the reason why, okay? I have no problem you choosing ace of 2 to be, ace of 1 to be 2. But they say that when they each contact 3 members, that's round number 1. So at round 1, after round 1 has been completed, it's been conducted, those 2 people, president and the treasurer, they contact 6. Okay, that's after the first round, only in the first round, how many people were contacted? Do you guys kind of follow what I'm saying? I just wanted to make that number consistent. Round 1, ace of 1. Then at round 2, because each of those 6 people will still make contact with 3 more people, so the ace of 2 will be 18, right? Because those 6 people keep on, just contacting, 3 at a time. And then for round 3, it's going to be ace of 3, which is going to be 54. So I kept on counting down that list, and then ace of 4 will be 162. Ace of 5 will be 486. And round number 6 is, I think, 1458, right here. And so the correct answer here is round number 6. The answer for this particular question is 6, okay? And here's the reason why. We want to find out how long it's going to take for all of these numbers to add up to at least becoming 1560. We want to contact all of them as much as possible. So after the first round, like Catherine said, we have those 2 people still intact, the president and the treasurer, but that's a total of 8 after round 1. After round 2, that's 8 plus 18, which gives you 26. Round 3, you add these up and you get 80. Then 242. Then you basically keep on adding the numbers, and no matter what you do, by the end of round 5, you only end up going up to 728 people by the time you get to round number 5. Okay, so that was hidden. But I want to contact every single members as much as possible. That goes up to number 1560. So I have to go up to round 6 to cover up to 1560. So the answer to this is round number 6. If you only go up to round number 5, you're short. Round number 6, you already hit your limit. So there you go. That should be the answer there. Yes, Olivia?
So for round 6, that 1458, that's the number of new people contacted.
That's right.
1560 is everybody total.
1560 is the least number of people that needs to be all contacted. So if you add these numbers together, you get around like 2,100 and. So there we go. So round number 6. We can't say like round number 5 point, I don't know, 5. I know it's somewhere between 5 and 6. 6 is way too much. You overshoot it, and 5 is undershooting it. But there's no such thing as round number 5.5. If you've ever been in if you ever watched UFC fights, you go round 1, 2, 3, 4. Like you don't go round 5.5. There's nothing like that. Quarter, like if you play basketball, quarter 1, 2, 3, 4. It's always integer numbers for that reason. So therefore, you're gonna have to just say that to cover it up. I hope this makes much more sense now. Yes, Olivia?
So for all of the types of word problems, we're going to be given round 1 or like something similar.
Yes.
Increase until a certain number or until a certain integer?
For this particular question, that's how you solve it. Because they ask you, how many rounds is it going to take for you to get up to 1560? Okay. All right. I'm assuming no more questions. So we're going to be moving on to the basketball. And I really like this question, but I also at the same time, I did not prepare you for this. Okay. So consider the ball that is dropped from a height of 38.28 meters and bounces back up to 60% of the original height. Okay, so that's common ratio of 0.6. I hope everyone could recognize that. And find the total distance traveled by the ball by the time it hits the ground for the 10th time. All right. So if you're one of these people that did this, which I totally don't blame you, so that's a sub 1, because summation, Mr. Kim taught us, the first term, 1 minus r to the n, 1 minus r, just plug it to the calculator, right? 1 minus to the 0.6 to the power of 10 over 1 minus 0.6.
Mr. Kim.
Yes, Bradley?
For that question, doesn't it like bounce up and down?
Yep.
So it goes double the distance except for the first one?
That's right. That's how I want you to think about it. So what Bradley is saying is this. If you guys did this, which I'm sure a lot of students have done because you want it to be very straightforward, this is actually not the case because in a real world context, a basketball or a ball, if it bounces, let's say, this height of 38.28, once it bounces, it's got to come up, right? That's 60% of the height. But whatever comes up must go down once again. So if you kind of count the height for this second bounce that it's going to make on this second hill, I'm going to type in, just for the sake of actually getting you the number, 38 times 0.6 or 38.28 times 0.6. This second distance is 22.968 meters going upwards and then going downwards as well. So you actually have to count that distance twice that the ball is traveling. Okay. Certainly did not accommodate for this. I did not prepare you enough for this. But so when you guys are ending up at the second bounce, okay, at the end of second bounce, what you have to add up is the first distance that the ball travels, which is 38.28, so it drops, and then it comes back up 60% of its original height, and then it also goes down the same amount. So I can just multiply that by 2. So that is the end of the second bounce right here. Okay, so this is after the end of the first bounce. This is after the end of the second bounce. And obviously, if you keep on working down this list here, okay, I'm going to move it to the left. The next one obviously is going to be 38.28 times 0.6. And I have to square that because it's going to be 0.6 times another 0.6. It's going to be even smaller than that. But as again, what most What goes up must come down. So that's what this times 2 is all about. Okay, so you're adding that on top of everything that you're doing. So this entire summation can be expressed as this. The very first term, which is 38.28, but you're adding with a common ratio of 0.6, but you're doing this 9 more times, because after this first bounce, you got to do this 9 more times to get to the 10th bounce, the 10th when the ball hits the ground 10th time. So you do this, but not only that, you have to multiply this by 2 to indicate the fact that it's going up and it's also going down. And don't forget your original height from the beginning. So whatever you get by typing this into the calculator, that should be your answer there. Okay, so the first height plus the first height times, the summation formula for geometric series, but you got to double that because it's going up and down. It's a good question. Ball, basketball moving up and down. It's a good question. It's related to physics. I like it. It's real world. But I did not prepare you enough yesterday. I did not give you enough examples for the word problems, which I'm greatly regretting. So I must apologize to you for this question, but it's okay. If you didn't do it, now that you know how to do it. And if I give you the similar thing next time, please be ready to understand what to be expected of you. Yes, Olivia?
Is it possible, I don't know if you are recording this right now, but to post?
Yes, I am. Yeah, one of my students also requests the same thing. I use YouTube, so I'm gonna just upload it to YouTube. Yep. But the problem is, 48-minute lesson publishing on YouTube, they take some time to get published. So just, I'll make sure that happens though.
Okay.
First thing today. All right, last question. This one was a little bit easier to understand, but again, it's a matter of, do you understand what a generation is and where you start from? Ace of 1. I really want to hear from you what ace of 1 is. What do you guys think the first term in this sequence would be? Catherine? 2. Did anyone say something different? So a student wants to find the family tree. 2 parents giving birth. Then grandparents giving birth to the student's parents. Then great-grandparents, and this is going to keep on going up and up and up, and that's what the family tree is about. What's the first term here? Some of the students at least, said 1. Look at that. You start from 1. But why should we say 2? Well, it's because we're talking about ancestors, right? Anyone that's above you, that's generation number 1. That's what I'm saying. I did not clarify this enough for you. So I had some students, there's a division among the students, say, oh, wait, the first number should be 2. No, the first number should be 1. I am this here because if your great-great-great-great-great-grandparents came from overseas to America, we call your great-great-great-great-grandparents first generation American. That's the first generation. So then their children will be second gen, third gen, and so forth. So let's say for me, I came from a different country. I'm a first gen American. So my kids will be called second gen. You guys will be like, I don't know, 6th, 7th, 8th, I'm not sure. But that's how I considered it. So the first person, the self, will be considered first generation. Then you count this as second generation and so on. But some students say, no, the ancestor starts from here. So you have to start from first generation from your parents' side. Then you start from here, the second gen, and so forth and so forth and so forth. By determining which number, where you start from the first number, you're going to get different answers here. And that's perfectly okay. And I will accept both of the ways because logically they both make sense to me. I will just use this just for the sake of, understanding what, just first gen, generation number 1, my kids will be generation number 2 and so on. However, because we're asked to find the number of ancestors after the 10th generation, you're going to still do the same thing where 1 times 1 minus, and the common ratio is 2, obviously, to the 10th power over 1 minus 2. But you want to subtract 1 if you decided to use ace of 1 as 1 because you want to count out yourself. Yourself is not considered an ancestor. I'm not an ancestor of my own, right? My parents are, starting from my parents beyond. So you have to count that out. If you started from here, 2 times 1 minus 2 to the power of n over 1 minus 2, assuming that you started the first generation as your parents, then that's okay. But these two are totally different numbers. They're very different numbers here. Okay. I'm not going to ask you to clarify. I'm not going to ask to, pick one, or I'm not going to ask you that, hey, do this all the time, because quite honestly, it's up to your subjective judgment. Okay, if you want to make sure that ace of 1 is 2, because based on the logic here, it makes that sense that parents should start from generation 1. I would accept it. Okay. If any case, if I want you to use this, I will be more specific in the word problems, as long as I'm the one that's designing these. Okay, I hope that clarifies things for you. And I'm gonna just briefly go over the next two problems on the worksheet. Olivia, are you okay? Can I move on? Yes, okay. All right, so algebraically determine the number of terms in geometric series, then find the sum. I have 1/81 all the way into 2,187. I want your verbal input for this, please. So Owen, let me start off with you. What's the common ratio here that you found? 3. Excellent. The first term, we can all see that's 1/81. So the n is the number that we really are dying to know. Did you happen to find out what n is? N was 12. And can you just elaborate for us as to how you did that?
I just did 2,187 equals 1/81 times 3 and minus 1.
And minus 1. So your task is to solve for n doing the old school way of just guessing and checking. I haven't taught you logarithms yet, in which it will allow you to solve for this really quickly. But let's do this the old school way. What's the first step I need to do to get n by itself here, Owen? Divide by 1/81, which is same thing as saying multiplying by 81. So these two would cancel out. So 81 times 2,187. 177, 147 equals 3 to the n minus 1. This seems like a crazy number, but as I told you yesterday, this will turn out to be 3 to something power. So I blindly guess 3 to the 10th. Oh, it's a little short. 3 to the 11th. Oh, there we go. 3 to the 11th gives you the exact same number as I see here. So I can just kind of use that as my answer. Then you add 1 to the other side and get n is equal to 12. At the end of the day, when you use these three components and plug it into your formula for the summation, 1/81 times 1 minus 3 to the power of 12 over 1 minus 3, because that's what geometric series is all about. Divided by -2, divided by 81. So my final answer here should be 3,280.49, 3827, if I want to write everything out. Okay, hope you guys, I know that's a crazy number, but that's what you should get. All right, one more to go. So I'm going to draw this little wall here. All right, so 4, -16, +64, all the way down to -65536. Common ratio here, Olivia? Oh, you thought it was arithmetic. Oh, no, that's not it. But, okay, so how do you go from 4 to -16? That's right. Ace of 1 is 4, and we want to solve for n. To sum up, to solve for n, we always use the explicit formula. Olivia, what's the explicit formula for the geometric sequence here? Ace of n is the first term times ratio to the raised to the power of, do you remember? N minus 1. Very good. So then I'm going to plug everything in. The last term, which is -65536, is equal to 4 times the common ratio to the power of n minus 1. Solve it the exact same way. Just get rid of the 4 for me on the other side like this. Cancel it out. -65536 divided by 4. -16384 is equal to -4 to the power of n minus 1. Like I told you before, that crazy -16,384 should end up being -4 to something power. I think it was to the power of 7, right? So if I do this right here, and I do this as 7, is equal to -4 raised to the power of n minus 1. You move that -1 to the other side, and you should get equal to n is equal to 8. All right, so all this work here, this number, you just blindly guess and check to find out what that number is going to get you. And then plug it into the formula for 1 minus -4 raised to the power of 8 over 1 minus -4. So 1 minus -4 to the power of 8 divided by 1 plus 4 times 4. Final answer, -52,428. Okay, that party you just let the calculator do its work. Yes, Nema?
Oh, did I see I did not get that answer, but I had the same formula as you. Same,
And I didn't get the answer to the first one either, but I had the same exact formula. You can use my calculator that time.
I'm gonna go up there personally and help you out. Because for the second one, my biggest worry is that you just forgot to write this parentheses around -4, maybe. Or for this one, you just forgot to, just write parentheses around these things. Okay?
So there's no parentheses around the -3. It's just around the 3.
Just around the 3, right? Because you want to tell the calculator, or you want to tell the calculator, 3 to the raised to the power of 12, which it will register to the power of 12 first. There's got to be something wrong with the way that you typed it. That's the only conclusion I can make of it. Okay, so I will be there to help you out. But in the meantime, I'm gonna move on to something that I have to teach you before we move on to the next week, and we do like study guides and things like that. What it turns out to be at this point, I really want to spend more time on this, which is called summation notation. There's a lot of cool things which we can do with this. There's a lot of different questions that we need to first tackle on. So I'm going to probably make an announcement for the rest of the classes as well, but I'm going to push. That assessment next Tuesday. I don't think we're ready for it yet. Again, it's going to fall on the B day, so I got to make it's most likely going to fall on the Thursday. That's what I'm going to shoot for. Okay. All right. So summation notation. On your notes, what I would like for you to do is I would like for you to draw this really nice. You can just write this down also for your title. Greek symbol called sigma. Okay. If you guys go to college, fraternity, sororities, probably have seen that somewhere. These Greek letters. And this sigma is they also exist in, Excels, like old version of Excels or any programs that you use. This symbol simply just represents sum of all the numbers. Okay. And the way that I always remember it is the bottom number always tells you where to start. So in the textbook definition, they tell you that that's the first value of whatever. And the top number tells you where to finish, to end. And whatever that goes in right there, because usually they will write down something for you. I just like to think of this as the formula that they want us to use. If you're ready to move on after you have written this down, I would like for you to write down this example in your notes, which says sigma that starts with I is equal to 1 all the way up to 6. Then I have the formula as 3i. And then if you guys could just draw out this table with I being on the top row with 1, 2, 3, 4, 5, 6. The reason for that is because this is where you start, indicated by this number at the bottom. And it also ends at 6, so I put 6 at the very end. Everything in between is what I have to get. Start to finish. So f of I, that means to use I value and plug it in here to find out what that number is going to be. So 3 times I when I is 1 here. Catherine, what do you think that's going to be? 3. Yep, it's not a trick question. You just have to plug in 1 as I and you're just going to get it. Catherine, what's the next number? Plug in 2 as I and you're going to get a 6. Plug in 3 and you're going to get a 9, 12, 15, 18. I believe we get the idea. So that is what summation notation is. You're going to take each and every single one of those I values from start to finish, plug it into the formula, regurgitate every single answer that you get. And with all of these numbers that in red, that's sigma. That's your last step that you're going to do. What are we going to do? We're going to take the sum of every single numbers that you have for this one. 3 plus 6 plus 9 plus 12 plus 15 plus 18. Well, this gives me 9. 9 plus 9 gives me 18. 18 plus 12 gives you 30. 15 plus 18, that's 33. So 30 plus 33 should give you 63 for my final answer. So notice what I'm doing here. You're doing this quite literally by hand, okay? Obviously, you can go to your calculator and type in 3 plus 6 plus 9 plus 12 plus 15 plus 18. But at the end of the day, this answer to this should be 63. Do you guys have any question as to how this is how this is done, like how this works? Okay. Then I want to ask of you guys to please try doing. That's way too much. Try doing this question for me, please, on your notebook.
Can we draw out the table?
You can. You don't necessarily have to do for this one, but you're evaluating each of the following. You're doing this by hand. You're showing me all the numbers that's in between from start to finish. So sigma I is equal to 2 all the way up to 5 of 4i.
Mr. Kim,
Yep.
if you would have like something just like that, but it goes to infinity, what would happen? Like,
That's going to be infinity.
oh, okay.
Because if you think about it, that means that it's 8, 12, 16, and all the way to infinity. And imagine if you're going to add all of these up.
Oh, okay.
Well,
Because I heard that it was like something weird, like diverging and converging.
This is something called diverging.
Oh, it goes to infinity.
Right. Diverging means it's going to infinity. That's what it means.
Oh, okay. And then what is converging?
Converging means it converges, it approaches to certain limit. Like,
Oh, okay.
like for example, if I gave you something like this instead, then
Okay.
this converges to 0. Because
Oh, because it would get infinitely close to 0, but never touch it.
right.
Oh,
So
okay.
it
Yeah.
converges to some value. That's what it means.
Oh, okay.
All right. So for this one, let's see. Emma, do you have the answer for this?
Yes, the total answer is
56. So I'm sure you did this 8, 12, 16, 20, and just add them up. And this is basic mathematics, like adding them up. And so this is going to be 20 plus 36, which gives you 56. Okay. So here's the cool part. I would like for you guys to now open up your calculator. Okay. And I am going to go to here. All right, so on the calculator, there's a really, really neat way for us to check our answers, not to use this and abuse it so that you can just get the answers right away, which I'm sure you guys will rely on this from time to time, which I have no problem with, but I need you to show your work by hand whenever it comes to these types of questions. On your home screen, please go to Math button right below Alpha. If you scroll up just once, okay, just press that arrow key up there. The fourth from the bottom that you see, this number 0, what does it say? Summation of sigma. Press enter. For the newer version calculators, you'll be able to see these little things. All you're going to do is just type them up. And then the calculator will understand exactly what it's talking about and then just output forth the answer. Owen and Olivia, do you guys get the exact same thing?
Yeah.
Okay, because the older versions, I'm sure you guys have, it looks like new. It's like a brand new version, so it's fine. But the older ones, they don't really have this capability, which is unfortunate. So here, how do I type this up? Well, just from the beginning, you guys should recognize that the cursor is already blinking A. That means it's alpha. That means the calculator has already inputted that it's expecting an input as a letter. The way that you're going to write in any, you can write any letters that you want, guys. You can write it as X. In the first question that we had, I believe we had I. Okay, it was I is equal to 1, right? So I here is in green. Test is A right here. If you guys take a look, test, or I mean math is A. In green, you guys have all of these letters that you want, you can pick from. I can pick X squared because I want to get I. I just want to make it consistent. So if I press on this, I get I is equal to. Then I'm going to say I is equal to 1 because that was our first question. Then on the top, I go up to 6, right? Because that was our first question that we had. And then I can type in 3. Okay, well, now how do I type in I once again? Well, if you want to get a letter again, you have to press this alpha button right here. You have to press alpha, make sure that that's highlighted, and then press I again, which is X squared. Press enter. I believe our answer for the first one was 63, wasn't it? So there we go. So why am I showing you this when you can just do this in your calculator? Well, first of all, you're going to be expected to do this by hand. Showing me all the work by hand. This is a way for you to check your answers. Okay? Let's do another one. Let's go to math, and you can just press 0 right away. So go to math 0. Then it's going to pop this up for you right away. The second one, what did it say? What did it say? It was K? K is equal to 1? No, K is. Oh, was it still I? Oh, I is equal to 2, and it went up to 5, right?
Yeah.
And then the numbers were 4i, I believe, right? So 4i. Hey, 56. There we go. Would I get the same thing if I used any different letters? Well, absolutely. I just like to use X because I'm so used to using X. Then you can do 4X, 56. Doesn't matter what letter you use. You can use A, B, C, D, E, F, G, whatever you want. Okay? So again, this is a way for you guys to check your answers with. And with the rest of the 10 minutes also, I'm going to show you guys just 2 key points. Why do we need this? Okay? Well, for the first part, you've already seen it. The question that you just did right there with the sigma notation, I is equal to the 5. If you notice, every geometric and arithmetic series that we did, we required a sub 1. Do you guys all remember that? We needed the first term to figure out what geometric series were or arithmetic series were. But look at this, the sigma notation. I can essentially take the sequence and crop out just one small component from the second term to the 5th term. I want to find out the summation. I can do even negative terms, even though that's not physically possible. For sigma notation, it can be because it doesn't really have any boundaries as long as you can compute it. You can start from -2 to 0. That's still counting -2, -1, 0 using this formula. Okay, you can crop out certain sections of sequences and you can compute it. That's one of the benefits of sigma notation. Does that make sense? Okay. One more thing. If you notice here, 8, 12, 16, and 20. Okay, so that's what we got for this part A. We already did this question before, just recently. What type of sequence is that? Is that arithmetic or is it geometric? It's arithmetic, right? Because we keep on adding by 4s. Even though this is 4 times I, well, that should be arithmetic because it's like mx plus b. Guys, if you guys do the same thing for the second problem, I guarantee you that's mx plus b, like a linear format. So you will get a linear function. You will get an arithmetic sequence. Take a look at D. I have -1, 0, 1, 2, 3. That's from start to finish. 2 to the -1 power, 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third. What do you think this type of sequence would be?
Exponential.
That's exponential, or we call this, I think I heard it, geometric, right? It's geometric. So this is going to be 1. If you guys type in 2 to the power of -1, I know that I haven't really taught you negative exponents before. If you typed it in your calculator, you get 1/2. Okay, then you get 2 for this, 4, 8, and so on and so on and so on. But this is a geometric. Okay. Now I'm going to show you one more. I've shown you arithmetic. I've shown you geometric. What do you think the third type I'm going to show you right now?
Recursive.
Nope, it's going to be neither of those two cases. So last time I showed you, wait, Owen, were you still writing stuff down?
No, I'm good.
You're okay? Okay. So let's say I give you a sigma notation that looks like this. The formula is k squared plus 1. Okay. Another benefit of using sigma notation is that this formula can be anything that it could be, and it doesn't necessarily have to be restricted towards geometric or arithmetic. K, f of k. 0, 1, 2, 3. Let's do this really quickly. Let's say I plug in 0 into the function, guys. Olivia, what would I get? 0 squared is 0 plus 1. So it's going to be 1. Owen, if I plug in 1 into this function, what should I get?
2.
It should get 2. Sorry, my Apple Pencil kind of died out of battery. So that's going to be 2. Catherine, if you plug in 2 in there, what am I going to get? 2 and then 5. And then last but not least, Emma, if you plug in 3 in there, what am I going to get? 10. Take a look at this pattern. 1 to 2. Okay, that seems like it's multiplying, but that doesn't work. So that's not geometric. I'm not adding by ones either. Do you see where I'm going with this? This is a sequence, a perfectly nice sequence of something called neither of those two cases. Yet you are still asked to solve for series of this type of sequence by using sigma notation. Okay? Before we go, I'm going to ask you to please do these two problems, and then we're going to check, and then we're going to end the session for today. You should be able to see that these two are nowhere near arithmetic or geometric. Once you're done, please check using your calculator, please. Catherine, are you not comfortable using this?
No, no.
Yeah, okay.
I'm out of notebook paper, so I'm still.
Oh, gotcha. You know how the third thing is?
Yeah,
Can you show me what you do?
okay, so.
So let me see
I
what
like the
you,
old one,
not this one.
not this one.
Okay. So, but first show me what you're doing. Let's say sure. This is the answer that I wrote for you guys.
Yeah.
Okay. So let's say that I do that. Mhm. Move it arrow, great. Okay, so here, do you see it? Let me just scroll here. You close one parenthesis, but you gotta close that outer parenthesis one more time. Maybe that's why. And then you divide that by. So now it's completed. You tell the calculator, hey, this numerator part's finished. Then you type in the denominator in the parentheses there. Hello? Yes, I do. Yes. Good. Olivia, after the class is over, go to the attendance office.
Okay.
Right, so I'm going to delete this portion. It's a little bit better. So when you did this on your first work, the one kind of criticism I'll do is that this multiplied by 2, you don't want to do this here. The reason for that is because you see how you wanted to add the 338.28. So if you were to do this entire thing like in parentheses, you want to do all of that. Actually, wait a minute, that's not what happened. You just want to multiply this by 2. This should be correct, the 62.446. I didn't give you the answer for this, by the way. I just wrote it like this on my note.
Oh, yeah, I do that.
Maybe,
Yeah,
yeah.
yeah.
So this is actually good. The one answer that I want to see is, you remember the last 2 questions in the homework?
Yeah.
Like you were solving for
Oh,
it?
yeah.
And you should that you were not
Yeah, I
able to get the
didn't
answer.
see that the answer. I didn't.
show me how you can do that one. Okay. That was your answer, right? One more thing. Parentheses, parentheses, parentheses around this whole thing to indicate this part not divided by the entire thing. That's the parentheses. Okay, so it's a matter of parentheses. Okay. All right, so I know that I'm running out of time here. Yes, so I only have 1 minute left. If you guys were to keep on plugging this in, to k and f of k, 2, 3, 4, 5. I'm gonna get these bunch of decimals and fractions. So first one, here we go. 5 over 2, 10 over 3. What is that? 17 over 4, I think. And then that should be 25, 26 over 5. Obviously, adding these, I'm not gonna ask you to do it literally by hand by getting common denominator. Just add them up. Just add them up by using your calculator and you will end up with the same thing if you were to just do math 0 and just type this in. So let me just do this for you guys real quick. 5 and then x squared plus 1 divided by x. Insert parentheses. And then your final answer is 15.2833. This should be the answer for the first one. For the second one, also k and f of k, you can also show, to show the answer by just doing it by hand. But also, let me just do this real quick. X equals to 2, 7, 400 minus x squared. 2,261, that should be the final answer for number 4. For homework, same thing, Sigma notation, use your calculator to check your answer, and please show your work as well, please. All right, thank you very much, guys. Have a good day.
Mr. Kim,
Yes, Bradley?
if you had here's an example. If you had an infinite series,
Yep.
or like the sigma, but the top part is infinite, and it starts from I equals 1, and then goes
Like this?
yeah, and then it was the function in it, I guess. Is that what it's called? Function?
Yep.
Is 2 plus 1
Kathleen, good luck. Yep. What's up?
is 2 plus 1 over 3i.
Like this?
No, like 2 and then plus, yeah, like that.
Yep.
Would the answer be it would converge for the limit as I approaches 2?
No, so you're saying that the limit will approach to 2, right?
Yeah.
Yes, it will be.
Oh, okay.
Yeah, but
Yeah.
the summation of all those numbers, that should still be infinity.
Oh, okay. It's the sum is always infinity, but it converges to a certain spot.
That's right.
Oh, okay. That makes sense.
All right.
Okay, bye.
Any other questions? Are you okay?
Yeah, I'm fine.
All right. Thank you so much. Have a good day.
Bye.
Bye-bye.